So we have got the graphs of f of x equals tan x minus 45 and g of x equals 2 sine x for the interval from minus 180 to 180. The questions are here next to it. We're going to go through those now. But before we get started, I don't know if any of you ever do this, but when I'm working with trig graphs, I always highlight the equation and then I highlight the graph for myself just so that it just kind of sticks out a little bit more and I can see exactly, not that I'm doing a very good job of highlighting this, but anyway, there we go. And then this goes down here. And let's highlight this one in a different color. So this is the graph of g of x equals 2 sine x. And it's over here. Let's just highlight that. And I think I ignored that little part of the tan graph over there. Okay. So just to remind you, when we are talking about our trig graphs, we are talking about them in the following form. So in other words, we would have y equals a tan b x plus p plus q. So we've got all of those different transformations to contend with, right? What does the letter A represent? Can anybody remember? What does the letter A represent? Good, it's amplitude. And what effect, if we increase the amplitude, so let's say the amplitude is 1 and we increase it to 3, what does that do to the graph? If I increase the amplitude from 1 to 3, what would that do to a graph? Can anybody explain that to me? Okay, so Nwazi says it will move up by 2 on the y-axis. Zachavatso says it will go upwards. Gugu says shift upwards. Okay, now unfortunately, when we want to shift a graph, it stretches it. Good, Lebogang. In which direction? Does it stretch it horizontally or does it stretch it vertically? Pumzi is correct. Okay, so it stretches it vertically. So this is a vertical stretch. Okay, so in other words, it pulls it this way. Okay, good, vertically. All right. What does the letter B represent? Exactly, our period. So B affects our period. And what does period tell us about a particular function? What does the word period mean for us with a trig function? There we go. Well done. Okay, so the degrees it takes to complete a full wave or the length of the graph. So it tells us how often the graph repeats itself, how often the pattern, exactly, how many times the pattern repeats itself. So how often, whoopsie, just ignore that, how often the pattern repeats. Okay. So for example, in a sine graph, if I had the graph of y equals sine 2x, the 2 represents how often the pattern is repeating itself in 360 degrees. So normally a sine graph would repeat itself once every 360 degrees. But if the value of b is 2, then the sine graph is repeating itself twice in 360 degrees. What is the period of a tan graph? What's the period of a tan graph? 180, absolutely. Okay, so it would normally repeat itself every 180 degrees. Good, well done, everybody. What does the letter P do? Good, well done, Cheslin. That is our horizontal shift. And what does the letter Q represent? That's it, our vertical shift. Well done. So just coming back to period, the period, depending on whether I increase it from 1 to 2 to 3 to 4, that will have an effect of squashing the graph. So this way, so it's a horizontal squash or stretch. If I have, for example, sine half x, it's going to stretch the graph horizontally. If I have sine 3x, it's going to squash the graph horizontally. So we've got to be aware of all of these things when we are working with our trig functions. Okay, so 6.1.1 says to us, write down the amplitude of G. Write down the amplitude of G. And sorry, the marks have kind of gone off the screen here. All of those are out of 1 and the last one's out of 2. So what's the amplitude of G? So Tsechofatso says it's 2. What do the rest of you think? Do you agree with Tsechofatso? Is the amplitude of G 2? Yes, absolutely. Okay, well done, Tsechofatso. Quite right. Perfect. So we would say 2, and that would get us 1 mark. Well done, Tsechofatso. 6.1.2, write down the period of F. What would the period of F be? You've all actually kind of told me this already. Yes, Tsechofatso, you hot off the mark today. Well done. It would be 180 degrees. Good. You're all saying that as well. Nice one. Okay, there's another mark. 6.1.3 says write down the range for the graph of P of x. If P of x is equal to minus 3 of G of x. So what are they asking us to do here? Anyone want to give us an answer here or tell me what you think would happen? Indeed, Nhlanhla. Okay, so Cheslin, it's not going to shift the graph 3 units up because what we are doing is we are multiplying our y values by -3. So I don't know if you saw what Nhlanhla put onto the screen, but that is correct. So in other words, not that you'd need to write this, but hopefully this just explains it a little bit more. You are going to take -3 and you're going to multiply that by g of x. So g of x is 2 sine x, like so. Okay, so that is actually going to give us the graph -6 sine x. Now they want us to write down the range, the set of y values. So what are our y values going to be? What's our range currently? I mean, if we didn't perform this transformation, what would our range for g of x be before we did the transformation? What would our range be? That's going to be our new range. Yes, absolutely. Okay, so Cheslin, you're quite right. Our current range, okay, our minimum is at -2 and our maximum is at 2. So currently our range is between -2 and 2. So what we are doing is that we are multiplying those numbers by -3. So our new range is going to be exactly what Nhlanhla put onto the screen. Okay, our new range is going to be, oh, let me just change the color here, is going to be y is greater than or equal to -6, but smaller than or equal to 6. Or if you wanted to, you could write it like this. So from -6 to 6. Okay, good. Well done, Nhlanhla. That's perfect. I think that was also out of 1 mark. Is everybody else happy with that? Does that make sense? Yes, okay. Oh, good. All right. And then question 6.1.4, the last question on this graph, asks us to describe the transformation of f to h. If h of x equals tan 45 minus x. All right, so let's just go up and go and have a look. Let's compare what these two look like. So f of x is tan x minus 45. H of x is tan 45 minus x. Okay, so what's changed? What's different? Can anybody tell me what's different here? Absolutely. Absolutely. Oh, sorry. So Pumzi says the 45 is positive and the x is negative. Yes, Segofatso, it's 45 minus x. Quite right. The signs have changed. Okay, so tell you what. Let's start with h of x. And let's do some algebraic manipulation. So we've got tan, and here we've got 45 minus x. So we know they did Lebogang. Okay, so we know that we are allowed to factorize, right? So let's take the negative out, okay? And then here we would have x minus 45 like so, right? So now essentially we have got a negative angle. Does that make sense to everybody? Our angle is negative. Does that make sense to everyone? I suppose I could do it like that if that makes a bit more sense to you. All right. And now the next manipulation I'm going to make, let's just do this on the side of here. If I have tan minus x like that, what happens? Exactly. Okay, so I end up with negative tan x. So I can do the same thing here. I'm going to end up with negative tan, and my angle is x minus 45. Okay. All right. Good. Well done. So now let's go back and go and compare that to f of x. So f of x is positive tan x minus 45, and h of x is negative tan x minus 45. So what has changed sign here? X or y? What's changed sign? X or y? Is x changed sign or y changed sign? Remember, you are comparing this to f of x, which is tan x minus 45. So y has changed sign, hasn't it? Okay, because here it's positive, and here we've got a negative. All right, so we've got a negative. Y has changed sign. So if y has changed sign, I have reflected my graph over which axis? If y changes sign, what have I done? That's it. I have reflected. So therefore, the graph of f of x was reflected over the x-axis. Well done, everybody. To give h of x. Okay, so this would be out of 2 marks. 1 mark would be for getting to that stage, and the other mark would be for saying that it was reflected over the x-axis. Okay. All right, nicely done, everybody. Are we ready to move on? Are there any last questions? Okay, we're ready to move on. Cool beans. Okay, let's go and have a look at the next question. So here we've got 6.2. Sorry, let's just rub all of that off. And let's read the information before we get started. So it says AC is a vertical flagpole. Cables are attached from A, the top of the flagpole, to points B and D on the ground. B and C and D are in the same horizontal plane. The height of the flagpole is X meters and the angle of elevation from D to A is theta. So that's this angle of elevation over here. Okay, so remember BCD, so I'm just putting blue dots on it. This is in the horizontal plane. Okay, and AC is our flagpole. Yeah, sure, Cheslin. So Cheslin just wants a couple of minutes to draw it. Or you're welcome to take a screenshot as well, Cheslin, if you want. So before we actually get started, what I just want to remind you about with a particular question like this. Well done, Nhlanhla, you're always so quick. Okay, Nhlanhla, you're welcome to continue with 6.2.2 if you want to. I'm just going to just talk to everybody else very quickly before I get started. Okay, so just reminding you guys about what's important in this particular section. If you are working in right-angled triangles, always use your basic trig ratios. So in other words, sine theta is opposite over hypotenuse, or tan theta is opposite over adjacent. When you are working in triangles that are not right angled, you need to use the sine rule or the cosine rule. Okay. All right. So when it asks us to determine the length of AD in terms of theta and x, are we working in a right angled triangle? Okay, Emma Maleng, I'm not sure why. Yolanda, could you maybe help Emma Maleng? She says she can't see the
Okay,
screen.
okay,
Thank
I'll
you.
be able to help her.
Cool, I appreciate that. Thank you so much. All right, so AD is part of a right angled triangle, quite right. So now we are going to use our basic trig ratios. Okay, we want it in terms of theta and x. So theta is our angle. X is what to theta, guys? Opposite or adjacent? X is what to theta? Opposite. Good. Okay. And AD is the hypotenuse. So if we've got opposite and hypotenuse, we have to use the sine of the angle. So let's start like that. Sine theta is opposite X over AD is the hypotenuse. Okay, and now we need to rearrange. So that means that AD will be equal to X over sine theta, like so. Is that okay with everybody? Yes. Cool beans. Lovely. Well done. All right, so we're going to get a mark for subbing in and a mark for rearranging it. Lovely. Let's do the next one. 6.2.2 now. And here, if cables AB and AD are equal in length and angle BAD is 2 theta, show that BD is 2x meters. So AB is the side over here. AD is that side over there. Angle BAD is this angle over here, and they've told us it is 2 theta. Which triangle are we working in? In question 622, which triangle are we working in? That's it. In triangle ABD or BAD. Good. Okay, well done, everybody. And if we've got a side angle side situation and we want BD, which rule are we going to use? Sine rule or cosine rule? What rule do we have to use under the given circumstances for this question? Sine rule or cosine rule? Good. Nice, everybody. Well done. We've got to use the cosine rule. Excellent. Okay, so now we need to sub into the cos rule. So we've got BD squared. Okay. Which is going to be equal to what? Can anybody tell me what I should be writing here? Or do you need your... Do you need your formula sheet, or do you know it off by heart? Okay, so it's BD squared is equal to, let's just see. Oh, you want the formulae. I was silly, Cameron. I actually had them on here and then I went and, okay, well, those formulae are not going to help us. Let's just have a quick look here. Okay, sorry, I thought I should have a formula sheet to hand, but I don't. If you know, you're welcome to carry on. I'm just going to get a formula sheet for you guys quickly. Sorry, just give me 1 second. This won't be long. If you can do this, you're more than welcome to go ahead. Okay, let's just cut this out and stick it on for you. Sorry, I should have done this earlier. There we go. All right. Let's have a look, Gugu. Yes, good, Gugu. Okay, you carry on. Yes, Mamelo. Yes, Nolwazi. There we go. All right. So some of you have got it. Hopefully you're continuing to work on this question. Okay, so BD squared. So here's your cos rule over here. All right, so the opposite side from your angle is BD squared. It's equal to AB squared plus AD squared minus 2AB AD cos A. So now we're going to go and sub in. We know what AD and AB are equal to. We've got that over here. So this is going to be x over sine theta squared plus x over sine theta squared minus 2 over, sorry, 2 into sine theta, and then here x into sine theta cos 2 theta, like so. Is everybody happy with that? Okay, should I stop there and let you simplify it on your own and let's see what you end up with? Give you guys a chance to do it rather than me doing it for you. Is that all right? You happy with that? Okay, you keep going. Okay. Zegofatso, I know you've, no, it's not Zegofatso, Ntlantla, I know you already finished. Just give us a second and just let everybody else catch up. I don't think I can put any more on the screen than is already there, so my apologies to you. Okay, and remember when you simplify all of this, we are trying to prove that BD is equal to 2x meters. So I'm just going to start working slowly behind you guys. Oh, you want me to explain it slowly, Amu? Okay. Um, how's everybody else doing? Amu, just give me 1 second. Do the rest of you want me to explain this, or are you still busy? Please explain. Okay. Oh, okay. All right. All right. That's fine. Okay. So maybe you're finding this is difficult, obviously, algebraically. Okay. All right. Not a problem. So do you understand what I have written in the third line? I've squared the numerator, squared the denominator. And then with my second term, I've squared the numerator, squared the denominator. Is everybody happy with that? Does that make sense? Okay. All right. And then when I'm multiplying the negative 2 in, remember, negative 2 is in the numerator. So it's negative 2 times x, which is negative 2x squared. And then at the bottom, it's sine theta times sine theta. That's why it's sine squared theta. And then I've brought my times my cos 2 theta down to the next line. Okay, does that make sense to everybody? And then I've got 3 terms here. Here's the first term. Here's the second term. And then I'm going to put a yellow circle around the third term because it's unlike the others. So the first 2 terms are like terms. So when I add them together, I've got 2 of x squared over sine squared theta. Is everybody happy with that? So I've now got 2 of x squared over sine squared theta minus 2x squared over sine squared theta times my cos 2 theta, like so. Everybody happy with that? So now I have 2 terms. Okay, so these are also unlike terms. So this term over here and this term at the back are unlike terms. So I can't minus the first 2 from each other, right? I have to factorize. So that means that I'm going to have to take out a highest common factor. What is my highest common factor? It's 2x squared over sine squared theta. So I'm going to take that out. And then in brackets, I would be left with 1 minus cos 2 theta. Is everybody happy with that? All right. Lovely, good. And now I want to pick something that is going to cancel out the 1. How can I cancel out the 1? So look at your formula sheet, and how can I replace cos 2 theta so that this 1 over here is cancelled? How can I get rid of that 1? What can I use from my formula sheet? If I use 2 cos squared theta minus 1, oh, you got stuck here. Okay, so. But if I use 2 cos squared theta minus 1, is the 1 going to cancel? That's right. Right, correct. Okay, so some of you have picked the wrong one. If I put in this one over here, 2 cos squared theta minus 1, the 1 is not going to cancel. Why not? Because you're going to have inside those square brackets, you're going to have 1 minus 2 cos squared theta minus 1. So now when I remove my round brackets, it's going to be plus 1. The 1's not going to cancel, is it? Can you see that? There we go. All right. So we've got to use 1 minus 2 sine squared theta, but we are substituting in a binomial, so we need to use brackets. Okay, so I'll bring out 2, whoopsie, that's supposed to be x squared over sine squared theta. And then over here, I'm going to do this. 1 minus 2 sine squared theta, like so. So let's leave the 2x squared over sine squared theta out there. And now I've got 1 minus 1 plus 2 sine squared theta. So now my 1 is cancelling out, and I've got 2x squared over sine squared theta. And then in brackets, I am multiplying this by 2 sine squared theta. Is everybody happy with that? Yes? So sine squared theta at the top divided by sine squared theta at the bottom is going to cancel. And now you've got 2 times 2, which is 4x squared. Now, we've long since forgotten that this was equal to BD squared. Remember, all of this is equal to BD squared. So if this is BD squared, then what am I going to do to both sides of my equation to get BD? I'm going to square root. Lovely. Okay, and that's how I end up with my answer of 2x. Okay, so just to remind you, they told us to show that BD was equal to 2x meters. All right, and we've managed to do that. All right. So it's out of 4 marks. Seems like an awful lot of working for 4 marks, but there we go. A mark for subbing in. There must be a mark on our factors. There must be a mark on using our double angle formula. And then I think the last mark here would be for getting to BD squared equals 4x squared. There's obviously not going to be a mark on the answer because the answer was given to us. Okay. How's everybody feeling? Cool. Lovely. Yes, of course you can. If you want to take a picture of the question, there you go, Tsechofatso, and anybody else. And of course, you're welcome to take a snap of the answer too. Better than before. Good, well done. So there's a lot of steps, and it seems like very confusing, but actually we do know what to do here, don't we? It's just a case of making sure that we pick the correct cosine double angle to get to the answer that we want. Okay. Very good question, Gugu. So Gugu's asking, how do we know when we use the sine rule as opposed to the cosine rule? Okay, so Gugu, you will use the cos rule when you have side, 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 or side, angle, side. So in other words, you are given 3 sides and you want to calculate an angle, or if you have a side and the angle in between, then it's the cos rule. Your sine rule gets used when you have a side and an angle, and then you can have another angle, for example. So this would be side, angle, angle. Okay, but with the sine rule, if you have got this side and the angle opposite and you've got that angle, you can only work out the length of the side over here. Or if you've got side, side angle, and this angle is not the included angle, then you would use the sine rule. Okay, so if I've got that side there and that side there, but I've got this angle over here, then I'm going to use the sine rule to calculate that angle. All right. Yolanda, please will you just help, I think it's Lati, if I pronounced your name correctly. Okay, you see, you get it, Gugu. Okay, so if it's side angle side and the angle's included, it's the cos rule. So like if you look at this question over here, it was side angle side, wasn't it? So we know we've got to use the cos rule. There are some situations where both will work. All right, but the sine rule is you can have two angles and a side and work out another side, or side angle, but it's not the included angle. So again, you can use it to work out a side or an angle. Okay. Okay. All right, cool. Glad you're happy. Let's go and have a look. We haven't got too much time. Yes, correct, Lebogang. So the only way you can use the area rule is with side angle side. Correct. Correct. So you need side angle side for the area rule as well. 100%. Good. Well done. It's good that you know that. Okay, so let's see how far we can get with this question. Hopefully we can finish it in the time. Oh, we should be able to do that without too much problem at all. Okay, in the diagram below, we've got the graphs of g of x and f of x. So let's just highlight those for ourselves. So g of x is cos 2x minus 45. So here is graph G. And we've got f of x equals 3 sine x. And that's that graph over there. Okay, so in 6.1.1, they want us to write down the amplitude of f. Who can tell us what the amplitude of f is? Good. There's a whole bunch of you that are saying that it is 3. Correct. Okay, so that should be out of 1 mark only. Lovely. Well done, everybody. There we go. Okay, next question. 6.1.2. Determine the value of x in the interval minus 90 to 270. So that's the interval for which these graphs are sketched, for which f of x minus g of x is equal to 3. So it only happens in one place because it says value of x, not values. So the difference in the y's on f to the y's on g, the difference is going to be 3. Where does that happen? Can anybody tell me for which value of x this is happening? Don't want to give you guys a chance to answer this without me telling you what it should be. Let's see what you say. Okay, so Cheslin and Gugu, yes, well done. Okay, so you just needed a chance to look at it. Good, well done, everybody. So this is happening at 90 degrees. So hopefully all of you saw that. Does that make sense to everybody? Are we cool with that? Yes, cool. All right, next question. So again, another describe the transformation. Okay. So you guys read question 6.1.3. I'm just going to quickly explain this to Ayanda. Okay, so Ayanda, if you have a look, okay, up here, what are the coordinates? 90 and 3. Over here, what are the coordinates? 90 and 0. Okay, so here at the top point, okay, where the 90 and the 3 is, that's f of x. Okay, so the difference over here is 3 units between the graphs. Okay, so the difference in the y's. Okay, 3 minus 0 is 3. Okay, that's why they said at 90. All right. Okay. 6.1.3, describe the transformation from f to h if h of x is that. Okay, so now you are making a comparison. We're going from 3 sine x to minus 3 sine x plus 30. Let's just see how many marks it's out of. It's out of 2. So there's probably 2 things that we need to say here. What would you guys say? What's happened? What have they changed? Can anyone tell me? Good, Lebogang, you're quite right. Yes. Okay, good. But Gugu, you're also correct, but there's also a horizontal shift that has taken place. If there is a horizontal shift that has taken place, make sure that you state by how many degrees and in which direction. Okay, so the rest of you that are maybe feeling a little bit shy, yeah, there we go. That's it, 100%. Okay, so we've gone from positive 3 to negative 3. So y has changed sign. So that means that we must have reflected the graph over the x-axis. So reflected over the x-axis and a horizontal shift of 30 degrees and a shift or translation of 30 degrees to the left or right, because it's plus, it must have been shifted to the left. Yes, indeed. Okay, so 1 mark for reflected over x-axis and another mark of a translation or shift of 30 degrees to the left. Beautiful. Well done, everybody. And the last question here, question 6.1.4. says to us hence. Okay, so now when we see the word hence, we know that we've got to use what we've just written down or calculated or described, whatever it is. Hence, determine the value or values of x for which h will be a minimum over the interval from 0 to 90. Okay, first of all, do we understand what the question is asking us? Okay, thank you, Tsechofatso. Sure. Okay, so we can't possibly begin to answer something if we don't understand what the question, no problem, everybody, if we don't understand what the question is asking us. Okay, so we now have a graph h of x. Okay, and when they ask us to determine the value or values of x for which it will be a minimum, all right, they're asking us for the smallest output, the smallest y value. We want to know what x value, the smallest y value will take place in the interval between 0 and 90. So what will be the smallest y value between when x is equal to 0 and x is equal to 90 in our transformation? All right, so if we consider what this graph is going to look like, okay? It's like the blue graph, except it has been reflected over the x-axis and it's been shifted 30 degrees to the left-hand side. So what was our maximum point would now be our minimum. Can you imagine if the blue line was reflected over the x-axis? Can you imagine that? So in other words, it would come from here. So we can't write it like that, Chesn. Remember, if we're writing an inequality, it's got to be, they've both got to be pointing in the same direction. So this point, if it was reflected over the x-axis, this point would now be 90, oh man, come, and -3, wouldn't it? Except we said that the graph was translated 30 degrees to the left-hand side. So now it's got to move 30 degrees in that direction. So what are the coordinates at the minimum going to be now? It's going to be 60 and -3. Exactly. All right. So now let's just go back and check our question. All right. The values of x for which h will be a minimum over that interval. All right. So where is it going to be at its minimum value? At 60 degrees, exactly. So here, this is going to be when x is equal to 60. Okay, does that make sense to everybody? All right. Good stuff, everyone. Well done. Okay, and obviously there would just be 1 mark for our answer.